Hello. Hi. Everyone can hear me fine? Great. Welcome to the Hydrogen and Fuel Cells and Batteries Group Exhibit 2016. Please have a seat and enjoy a non-alcoholic beverage on the house. Please help me welcome Professor Dr. Anke Hagen, the head of section at DTU Energy FCH Test Center, Technical University of Denmark. Welcome, Doctor. Thank you very much. And as you probably already know, anytime, feel free to ask any questions, and we will answer them right then. I'll just call you Anke, if that's okay?
Fine.
Perfect. So Denmark has political goals and has decided to change their energy sources by 2050. Can you tell us about this a little bit?
Yeah, it's maybe a good continuation where the last discussion stopped about politics. So in Denmark, the government has decided to be independent on fossil fuels by the year 2050. This is quite an ambitious goal. That means at that point, we don't want to use natural gas, oil or other fossil fuels, coal for example, but rely completely on wind energy, solar, biomass and other technologies to produce both electricity and also to provide fuel for the transport sector. And I can say that we are in Denmark quite good on the path towards that goal. So we have extended our share of wind energy according to the plan. And so we are quite optimistic to reach that goal by 2050.
What challenges, if any, do you see with that change taking place in Denmark?
Yeah, as everybody knows, when you rely on renewable energy sources like solar and wind, the challenge is that the production pattern does not correspond to the consumption pattern. So the wind is blowing very arbitrarily, often when you don't need electricity, for example. We have already now situations in Denmark that you have to stop a wind turbine because the electricity produced cannot be used by the consumer. On the other hand, there might be situations where you need electricity and the wind is not blowing or the sun is not shining. And of course, Denmark is embedded in infrastructure internationally, power and gas, but also other European countries close by, they have the same goals. They extend wind energy, so at some point you cannot, by trading, get rid of this problem. This is one challenge, and the next challenge is to provide fuel for the transport sector. So there you need solutions that you can either use battery cars or you produce the fuel based on renewable energy sources. And that is actually the main areas that our department, DTU Energy, has dedicated research to.
Fantastic, thank you. Can you please tell us a little bit more about DTU Energy since we're on the subject?
Yeah, so our whole name is Department of Energy Conversion and Storage. And we work with technologies such as batteries, fuel cells, hydrogen storage, electrolysis in different versions. We are about 230 employees, researchers, PhD students, technicians and so forth. And our keywords, you can say, is we are cross-disciplinary and we have a vision to enable sustainable technologies in the society.
Thank you. Could you share some of the examples of your research done at your department?
Yeah, I'm heading a section called Applied Electrochemistry. Our main activities are devoted to solid oxide fuel and electrolysis cells, among other technologies. And I can give a short example how we approach research and development of this technology in my section. I could illustrate like you bring your car to a service and they connect your car to a computer, and then afterwards you get a report. Okay, you need a new cooling liquid, you have to exchange the brakes and the air condition has to be repaired. So you get a detailed report, and that's precisely the approach we have in my section. We get a fuel cell or a fuel cell stack and then we test it, and then afterwards we want to know in detail how all the different parts of these cells or stacks perform. I don't want to become too technical, but a fuel cell consists of many layers. Some of them are porous, some of them are tight, some have to conduct electrons, other ions, and this is a very complex system. And by testing we want to find out how these single steps play together and where are the bottlenecks, for example. And then we give this knowledge to our colleagues, for example, that are experts in microstructural analysis, and we say to them, please look into this layer, and can you find out about pore structure, for example. And then our colleagues elaborate and study the structure, and then together with us, we go to our manufacturing colleagues and say, okay, we have found out that in this fuel cell, some layer is not sufficiently porous. So in that approach, we are working across the different disciplines to get a fundamental understanding at the first point, and based on that, be able to improve, in that case, a specific case, solid oxide fuel cells or electrolysis cells.
Thank you. Your topic being Danish activities on SOFC and SOEC, from fundamentals to mature technology. What is your department's contribution in order to mature the technology and actually bring it into the market?
Yeah, we have from the beginning, and you can say in the 80s, we started with this research, and at that time it was very important to develop and find the right materials for the solid oxide fuel cells. Now we are at a stage that there are well-performing and durable fuel cells available, so they have matured, and we have in parallel matured, you can say. So as a research center, initially, we were very much interested in materials development, making cells. At the same time, we were also interested to mature the technology. That means we wanted to make the world's best cell, but we also wanted to make them in many thousands, tens of thousands pieces. So we were starting scale-up activity where we installed a pre-pilot manufacturing line that enabled us to produce 10,000 of cells per year. So in parallel with the technology maturing, we also matured our research. We also went from a cell development now to stack development. We also look at the system to see how the solid oxide cells can be embedded in new energy systems of the future. And maybe the final step in late years to mature the technology was by establishing of our test center, FCH Test Center, which is dedicated to help, in fact, commercial companies to come faster to the market with the solid oxide fuel cell and hydrogen and electrolysis technologies. And what do we do precisely? We offer tests of components and cells and stacks to companies. We offer also training. You can say, okay, what is the specific benefit if a company comes to us and wants to buy on commercial basis some testing? And I can tell that we can offer many years of experience, and the technology is not kind off the shelf. So it is not you will have a cell and then you put it into a device and test it. Actually, we have seen also in other projects, you need to rely on many years of experience. That can be some technical, simple questions that have to be correct. It can also be the equipment that you need. And we have quite a large advanced technical equipment at our department where that can be offered to be used to solve problems, challenges of the company, of the specific company. And as I mentioned, we do it on a commercial basis. We can also collaborate in projects. We are part of many European projects. For example, the big demonstration project Enefield, which is the largest European project for demonstration of stationary micro-CHP units. And when we collaborate with industry, we have many years of experiences. We know they want to have strict confidentiality, and we can handle that. They also want to know what's going on, and we have a very tight communication. So they always know where we are in our tasks and activities, so they know what they are paying for and where we are in the progress on the process. And maybe the third is also that we have developed quite good documentation, which is very important for all kind of also industry and development projects. That we have a long history of documentation from a very detailed level. So if you are a company and come to us with some problem, be it a cell you want to know about, performance, durability, be it interconnect sheet and knowing how it can withstand corrosion, we can offer quite advanced equipment and outstanding, I would say, know-how to tackle this problem. And it's for the company almost as they are present at our place, because we have good documentation and good communication skills with the industry.
So you keep a really close relationship with your clients and your lab as well. Can you talk about the funding you receive, or the DTU receives?
Yeah, this is of course the Alpha Omega funding. We are now a university, so we get some basic funding, which is also used for education, training, teaching students, which is also actually quite a big challenge that should not be underestimated. All the new technologies we present here and which we develop, they will be eventually, hopefully, in the society, and then we need people who can handle those. And that are the students from today. We also can educate technicians, for example, or professional people. So a part of our funding comes from university. We have also a big share of funding from European sources. We are quite active in the joint undertaking, fuel cell and hydrogen undertaking, which is also necessary. And the ENEFIT project also demonstrates big demonstration projects where all the big players in the field are partners. It also shows that we need, even competitors need to work together to finally achieve commercial technology that has a breakthrough and is successful. So European funding plays a major role also to share the needed expenses for such a big undertaking. We have also actually quite a good funding situation, fairly good in Denmark. Initially, I told you that we have this ambitious goal, which puts actually a number of people under slight pressure. The utilities, for example, that are those companies that provide electricity and heat to the consumer, to the customer. They have to accommodate more and more renewable energy sources, which are fluctuating and with all the challenges I mentioned. And they also have some resources devoted to projects. They also invite projects with foreign industry, for example. So we have been fortunate to get quite good funding for our solid oxide fuel cell and electrolysis research in the previous years. They also require very close collaboration with industry. That's why we also have a good track record for collaboration with industry. And lately we have maybe more and more also looked at commercial collaboration with industry, which then has again some other requirements, for example with regard to confidentiality. So there are different levels of funding, and we try to get the right funding for the right activity or problem we want to solve.
For the right project. Can you share with us a bit more examples about the testing that they do at DTU?
Yeah, I already mentioned that I think we are among the world leaders when we get a fuel cell and then have to characterize it in very detail. We also have experiences in long-term testing, so we test fuel cells or stacks over several months or even years. We try to be as applied as possible, so to use conditions that are very close to real-life conditions. That includes that we want to apply the real fuel. It could be biogas, it could be natural gas, or it could be reformed ethanol or methanol. In regard to the electrolysis, we also look a bit further, use that as a technology where we can provide fuels for transport sector. So we are converting electricity produced from renewable sources into a fuel that can be used in the cars of today. So not everybody needs to buy a battery car, so we can maybe in the immediate term continue with our current car fleet. So these are a few examples what we can do. In addition to that, maybe more specific examples, we have some know-how and equipment to do mechanical testing, and when you work in the fuel cell area, you might know that mechanical properties are quite important for this type of fuel cells, and we are able to characterize them under real conditions. We are also going towards direction to characterize and test materials under conditions that very close to real-life conditions. So away from ultra-high vacuum and very pure gases, we look to real-world conditions. And that's, I think, one of our focus areas and something where we have some strengths compared to other players.
Fantastic. Very much more practical. So when people go home today, what is it that you really want them to take with them about your talk and about what DTU does?
Yeah, I think we have a good fundament for developing the technologies mentioned here, SOFC and SOEC. We have a long track record of research, but we are also quite attractive and eager to help to commercialize these technologies, and that's also in our own interest. We are a university, we want to do research, and we are also rated according to our research. But we can only be successful if these technologies eventually come out into the market, because then we can develop the next generation fuel cells, for example. So it is in our own interest for the future research, and also in our interest to let the money that is already spent and time and hours on this research, that it pays off in the future and we achieve our goals, climate goals, for example.
Great. Anything else that you would like to share? Since we have a little bit of time.
A lot, but
that will fit into a little bit of time.
I think I have presented our department, which has the mission to be interdisciplinary and to enable sustainable technologies for the society. So I hope that this department, I could show that we are not a university department that is striving for mainly good publications. We are also striving to get the technology out, and we are also able and willing to do our share for that in collaboration with industry.
Okay, well, thank you very much. And we'll just, we will invite you to go visit, thank you, yay! We invite you to go visit DTU Energy in booth D62/2, which is right behind Green Light Innovation here. And thank you to Dr. Anke for being with us.
Maybe one appendix. We have 2 technical presentations later today about this big European project Enefield. In the afternoon at 3 o'clock in the technical forum, and on Thursday we will also give a more technical presentation on our activities. On Thursday, 10:40 around there.
Now you can clap. Thank you so much. Please stay for our next interview with Catherine Smith, Commissioner at the State of Connecticut DECD, and Joe Reinbold, Director at Connecticut Center for Advanced Technology. Thank you.